Hello class, and welcome to section 1-7 day 2, which is about absolute value inequalities. By the end of today's lesson, you will be able to solve inequalities that involve absolute values. When you are solving inequalities with absolute values, there are two different types. The first type is going to be the AND case. This happens if your inequality involves less than or equal to. So for example, if the inequality said x plus 5 in the absolute value is less than 7, this would be an AND case because the symbol, your inequality symbol, is less than. On the flip side of that, we have our other type, which is the OR type. This is saying that it is greater than or equal to. So for example, if you have x plus 5 in absolute value is greater than or equal to 7, then you are going to follow the OR type. Either way, each type has two cases. The first case is positive, so just like when you were solving inequality equations, you keep the answer positive for that first type. So in this problem, we would have x plus 5 is less than 7. And then the second case in this one would be the negative case. X plus 5 is greater than negative 7. So we take our inequality here and we keep the symbol for the first one, less than, and flip the symbol when we make it negative for that second one. The same thing would happen with the OR case. So if we start with x plus 5 is greater than or equal to 7, then our second case we would flip it, x plus 5 is less than or equal to negative 7. So this first case would be and the second case would be OR. Why is the AND or OR important? The reason it's important is because AND is talking about one interval. So it's talking about one group of numbers and saying that it's within those numbers. So if you were graphing it, it would be between those 2 points would be your answers. The OR situation means that it is outside, or it creates 2 different groups of answers. That would be on the graph looking like something going to the left and something going to the right. Now, a couple other things that I want to talk to about is interval notation. Interval notation is a way to write out these answers without using the actual inequality symbols. So with interval notation, we use brackets and parentheses to stand for our open and closed dots. If it's closed, you're going to use these square brackets. That's the equivalent of the filled in dot. So if you were graphing, you would have something that looks like this, or you could have, if it was an OR statement, something that looks like this. So those square brackets replace the filled in dot. On the flip side of that, open brackets, aka parentheses, replace the open dot. So if it was an AND statement, it would be parentheses with the line in the middle. If it was an OR statement, it would be parentheses on the end without the arrows. In terms of how this is written, this is an example of the closed brackets with an AND statement. So this is saying negative 7 is less than x, which is less than 8. So it's in between 7 and 8. And because it's closed brackets, both negative 7 and positive 8 are included. The OR statements mean that there's 2 different intervals, and we have this U shape in between them. That means there is a space between our answers. When you are writing an OR statement, you always start with parentheses, negative infinity. So that's the arrow part down here, saying it goes on forever to negative infinity, and then it goes up to, in this case, I just picked negative 1. So that would be a closed bracket on this side. On the other side, it's saying start at 5, so that would have been an open parenthesis, and go all the way to infinity. That's how it shows an OR statement. So, solving and graphing. This first one is just super basic. It's saying the absolute value of x is less than 5. So we need to split it into case 1, keep it the same, x is less than 5, and because it started as less than, x is greater than -5. So that would be how you would write it out the long way. If you were writing it out in interval notation, you would be writing it as one group. So starting at the smaller number, so we go from -5 all the way to +5, and we put the brackets, the parentheses on the outside to say that everything is in between. On the graph, if it wanted you to graph with dots, we would go to -1, 2, 3, 4, 5, and do an open dot, and +1, 2, 3, 4, 5, and do an open dot, and have your graph in between. You can also, if it was asking for the interval notation, we would use the parentheses and then put the line in between. So those two graphs, the red and the green, show the exact same graph, just depending on what kind of notation it is. Regular notation with the dots, or interval notation with these parentheses. On the flip side down here, again, it's a super simple problem, but we're going to start with x is greater than or equal to 5. Since we started with greater than, this is now an OR statement. X is less than or equal to -5. Once again, we can turn this into interval notation. So what this one is saying is we've got x is bigger than 5, but x is also smaller than -5. So we would start with our smaller part. So coming from -infinity, we're going to go up to -5. -5 has the equal to sign, so we're going to put our square bracket. Then the OR means leave a space, so that's what that U means, leave a space, and then we're starting at +5 and going all the way up to infinity, which we can't touch, so it gets that parenthesis again. On the graph, we would go -1, 2, 3, 4, 5. If it wanted regular, you would do filled in dot and go arrow to the left. And then on the flip side, 1, 2, 3, 4, 5, filled in dot with an arrow to the right. If it wanted that interval bracket notation, you would have the square bracket going to the left and going to the right in matching fashion. So again, different notations, all of them tell you the same answer. Now we're going to get into one that has a few more steps. Here we've got 2n minus 18 is less than or equal to to 2. First, we're going to notice that this is less than, so it is going to be an AND statement. Then you need to set up your two problems. So 2n minus 18 is less than or equal to 2, and 2n minus 18 is greater than or equal to -2. Flip the sign, make it negative. Now we need to go through and solve the problem. Step 1 on both equations, both inequalities, is going to be to add 18 to both sides. In your first case, you're going to have 2n is less than or equal to 20. And in your second case, you're going to have 2n is greater than or equal to 16. Now in both cases, to continue solving, you're going to go ahead and divide by 2 on both sides of your inequality. And your first answer, you get n is less than or equal to 10. And the second answer, we get n is greater than or equal to 8. So, writing this as our final answer, if I wanted to put this in interval notation, it's an AND statement, and we have an equal to, so it's going to be between 8 and 10. So our answers are going to be between 8 and 10, which means if I come over to the graph, I'm going to have my brackets at 8 and 10 and mark off the space in between. Same thing's going to happen if we have an OR case. So now we've got a greater than or equal to. So this is an OR. So we've got 3x plus 3 is greater than 18, or 3x plus 3, flip the sign, is less than, make it negative 18. Going ahead, starting to solve, subtracting 3 from both sides of both inequalities. And with the first case, you end up with 3x is greater than 15. Or our second case, which is 3x is less than negative 21. Both of these, you are going to go ahead and solve by dividing 3 on both sides. And that's going to give you your first answer of x is greater than 5. And your second answer of x is less than negative 7. Now we need to write this in our interval notation. So we're going to start, this is an OR, so we're going to start at negative infinity, and we're going to go up to our first value, which is negative 7. It doesn't have the equal sign, so it's a parenthesis, and then we're going to leave our space symbol, so that connection U, and then we're going to start at 5 and go all the way up to positive infinity. When we put that on the graph, we're going to start at negative 1, 2, 3, 4, 5, 6, 7 with our parenthesis, and our answers are getting smaller. And then on the other side, 1, 2, 3, 4, 5 with our parenthesis, and then our answers are getting bigger. Go ahead and try this one on your own. We end up with an OR case. Your first answer being y is greater than 3. The second one is y is less than negative 4. Less than or equal to, negative 4. So we have that bracket at negative infinity is less than 4, connection 3, and then going up to infinity, and then we have our graph. There are 2 other scenarios that I want to talk to you about that involve negative answers to our absolute value. So, as we have reviewed in previous lessons, absolute values are always positive. So whatever I plug in for n, this is going to turn into a positive answer is less than negative 3. It is not possible for positive numbers to be smaller than negative numbers. So if your inequality is less than a negative, this is a no solutions problem. There is no answer where a positive number is less than a negative number. If you come down to this next case, again, your absolute value is positive, and now it's saying it's greater than negative 9. As we know, all positive numbers are greater than negative 9, so in this case, it would be all or infinitely many solutions. It doesn't matter what you plug in for n, it's always going to be greater than negative 9. So, just recapping once again, if the absolute value is greater than a negative, the answer is always all solutions. If the absolute value is less than a negative, the answer is no solutions. Last thing we're going to do is we are going to talk about a word problem. So the debate team is traveling for a tournament and will spend 4 nights in a hotel. The cost for each team member must be within $20 of $175. Which of the hotels pictured can they consider? So I just want to refresh your memories here. When we're talking about absolute value equations, we have x minus that central value, and then we're going to have our inequality symbol, and then it used to be equal. In this case, we're going to change it to less than or greater than. And then we have that difference, so how far away we can be from that center point. So a few things I want to point out in this particular equation. First, they are spending 4 nights. So instead of just being x, it's going to be 4x. And then our central point, it needs to be around $175. So that's going to be our center. And then it's saying within. Within is going to be an and statement. So we're going to have less than, and it also could be equal to, because they could spend $175 or they could spend up to $20 more than that. So what they could spend and how far up or down they can go from 175. So that's going to give you your equation. Now I want you to go ahead and solve it and then decide which of the 3 hotels, if any, they should consider. So once you solve your equation, you're going to get, for the first one, it has to be less than $48.75, and for the second one, it has to be bigger than $38.75. So the 2 hotels that fall within $38.75 and $48.75 are going to be Hotel A and Hotel B. If you have questions about this or anything else from the lesson, please let me know when you get to class.